Hi, welcome to my video on graphing a polynomial by finding its x and y intercepts, increasing and decreasing intervals, maximum and minimum points, and finding the intervals of concavity where it's curved up and down. This is number 3. This is one is a little tiny bit different, so that's why I'm doing a third one. Graph y equals x cubed minus 2x squared plus x minus 2. Again, notice this is a cubic, and cubic polynomials have at least one real root, but the other two roots could be imaginaries, or they could have a double real root and another real, or they could have 3 separate distinct real roots. So let's look at what we have here. Y equals, and I notice that we have an x squared, so this is x squared in the first two terms. So that's an x minus 2. And we got a plus 1 coming out, and so that's an x minus 2. We take a plus 1 out. So that's y equals, we have an x minus 2, which is a binomial that's common, so this is x squared plus, and again that's understood to be a 1 there. So notice when we let y equal to 0, that means we have x minus 2 is equal to 0, or we have x squared plus 1 equals 0. So that means you solve this one for x, you get x is 2, and right here we have x squared equals negative 1, x is equal to plus or minus the root of a negative 1, x is equal to plus or minus I, that's imaginary. So we have 2 imaginary roots and a real root at 2. Also, if you look at this closely, this is like a parabola. Y equals x squared plus 1. So what happens is that whatever value of x you pick and you square it is always positive. So that's why if this is always positive, adding 1 is positive. So this is always greater than 0. So that's why there's no value of x here. So that's why it's imaginary. There's another way to see it. So we have x-intercepts at x equals 2. So that's right here. So that's this point right here. So that's the point. X is 2, y is 0. So that's this point. So that's a 2. 2 comma 0. Okay, we label that point. Now, you'd say, well, where's the imaginary roots gone? Well, there's a bend in this graph somewhere. But this is where we're doing calculus to find this bending. So what about if we do the derivative? Derivative gives the slope of the tangent. So the derivative here is a 3x. 1 times 3 is 3. Make that a 2. And negative 2 times 2 is negative 4. And we make this a 1, we subtract 1 from 2 to get 1. And the derivative of 1x is just 1. That's a 1 there. Again, that's a 1 times 1 is 1. Decreases by 1, you get x to the 0, which is x to the 0 is 1. So that's a 1. Derivative of a constant is 0. So notice now that we have a quadratic. And let's see if this quadratic, if it's good, we got a 3x and an x. The factors of 1 are 1 and 1. Product is positive, sum is negative. So it has to be 2 negatives, so negative 1 and negative 1. And the FOIL, 3x times x, 3x squared. Negative 1 times negative 1 is 1. Outside is negative 3x, inside is negative 1x is negative 4. So that means if we make y prime equal to 0, so you have 3x minus 1 equals 0, or you have x minus 1 equal to 0. So 3x is equal to 1, x is 1/3. X is 1 here. And there is another way to deal with this factoring. We could do with synthetic division. Notice that these coefficients of 3, negative 4, and 1 add up to 0. So that means if they add up to 0, we can try 1 in synthetic division. So we got all the terms here descending, so it's 2, 1, 0 in terms of powers, because that's x to the 0. So we got a 3, negative 4, 1. So synthetic division, bring down your 3. 1 times 3 is 3. Add negative 1. 1 times negative 1 is negative 1. Add, we got 0. And that 0 is what I call the remainder. So that means 1 is a root. So 1 is a root, x minus 1 is a factor. X minus 1 is a factor, 1 is a root. So now we have a depressed equation. So we got 3x minus 1. Because this is equal to 0, this is an x and this is a constant. So notice this is a quadratic. When you divide x into x squared, you get an x. So this is 3x minus 1 equals 0. So now we're working it out to be 1/3. So there's another way to do these two. Now, if the first derivative is the slope of the tangent is 0 at x is 1/3. Let's take 1/3 and put it into this equation. So y equals 1/3 cubed minus 2, 1/3 squared plus 1/3 minus 2. Take our time, work the powers first. So we have 1 cubed is 1, 3 cubed is 27. And we got 1/3 squared is 1/9. 1/9 multiplied by negative 2 is a negative 2/9. Plus 1/3 minus 2. So the common denominator is 27, so that's 1 over 27. Minus, make this is 27, so we multiply by 3, so 2 times 3 is 6. We make this is 27, common denominator. 3 9s are 27, so 9 times 1 is 9. And we have a 27 here, so we put it over 1. So 27 times 2 is 54. So that gives us a 27. And so it's a 1 minus 6 plus 9 minus 54. And when we add all that up, we'll get a negative 50 over 27. So this point is 1/3 and a negative 50 over 27. Now, so that's approximately 1/3. So a negative 50 over 27 on a calculator is about a negative 1.85 approximately. So I'm using a decimal to graph it. And we have x equals 1. So when x is equal to 1, we're going to, let's put x equals 1 here and write the equation. Y equals 1 cubed minus 2, 1 squared, plus a 1 minus 2. So that gives us, so I put a 1 in the place of x here. Everything is okay, looks good. So 1 cubed is 1, 1 squared is 1, so that's negative 2, plus 1 minus 2. So that's 2 minus 2 is 0, so this is a negative 2. So this point right here, 1, negative 2. So that means this is, let's take the point 1, negative 2. That's right there. Okay, and let's take this point, 1/3. 1/3, that's a half here, so 1/3 is right here, and this is almost a negative 2. So it's, let's take it to be right there, that point there. Okay. Now, what we didn't do, and I didn't do, is that I found I found the x-intercepts, but I didn't find the y-intercepts. So if I got to find the y-intercept, so the y-intercept is when I let x equal 0. So if I let x equal 0 here, this is a 0, x is 0, this is a 0, x is 0, this is 0. So that means y is negative 2. So this is the point, x is 0, y is negative 2. So there's the y-intercept right there. And as it happens, if you look at the y prime, which is right here, the y prime, we have 1/3 and a 1. So we got a 1/3 and a 1. How's the slope of the tangent going? When we make y prime equal to 0, we got these two values of x. So we're going to check at a 2. We're going to check at, 2/3, let's say, which is between 1/3 and 1. And we're going to check with a 0 to see if how the slope is going. We can take a guess without doing this. I'm looking at this as positive. So that means it's coming down through this x-intercept here. And it's coming down through here. And it looks like it's getting down here and it's bending. Look, I can see it now. There it is, right there. Coming down here, and it hits here. It's going back up to here. So this is where we have this point, 1, -2. So it looks like this is a min, and it looks like this other one is a max. But let's check that out here. Let's take a 2 and plug a 2 into this factory. We put a 2 in here, we get a plus. Put a 2 in here, we get a plus. So a plus and a plus is a positive. Put 2/3 here. 3 times 2/3 is 2. 2 minus 1, positive. Put 2/3 here is negative. So we got a positive and a negative, which is a negative. Put a 0 in here. 0 in here gives us -1 and -1. So it's a negative, and a negative is a positive. So that means on between 1, so it's 0 here, and 0 here. So at these 2 points, we're getting to the right side, we got a positive. So there's the right side of the 1, so that's positive. And we got a peak point here and a peak point here. So it looks like it's coming down through here like this. And at 1, 2, the derivative, first derivative is 0. So that's the max, and now it's going back up to here. And then it's coming, so this is negative, so this is the negative slope here. And it's positive after 1/3, so there's the 1/3 right there. There's the point, which is this one. And then it's positive again. So there it is, doing this. So it's positive here, negative here, and it's positive there. And what about the inflection point? Let's see where the inflection point is. So let's do y double prime. Y double prime, and this is y right here. This is y prime, so double prime. 3 times 2 is 6, and it's an x. And -4x derivative is -4. And the derivative of a constant is 0. So y double prime is equal to 0. So that means we have 6x minus 4 equals 0. 6x equals 4. X equals 4 divided by 6, or 2/3. So this is, so we have 2/3. So the double derivative, which is the concavity, which is the inflection point, occurs when y prime is equal to 0. So this is occurring at where x is 2/3. So let's take the equation, which is this equation, and put 2/3 in here. So we got 2/3 cubed, -2 times 2/3 squared, -2 times 2/3 squared, and we got plus 2/3 minus 2. So let's take our time and work out to see where this point is. 2 cubed is 8. 3 cubed is 27. 2 squared is 4. And -2 times 4 is -8. and 3 squared is 9. So that's a 4 over 9 multiplied by negative 2 plus 2/3 minus 2. And we get our common denominator is 27. So let's take, that's an 8. 9 times 3 is 27, so 3 8s are 24. 3 9s are 27, so 2 9s are 18. That's over 1. So 2 times 27 is 54. So we have, let's add all that up, and works out to be negative 52 over 27, which is approximately negative 1.93. I had to go to 2 decimal places because they're so close. This one was 1.85. So if I call this one a 9 and call that one a 9, they would have been hitting each other. So this point is 2/3 and a negative 1.93. So that's 1/3. So 2/3 is here. So 1.93 is close to a 2. So it's approximately, there's the inflection point here. So that means that on the right side, it's positive, going upward, and on the left side is negative, going downward. So let's go and look at that. So we got the inflection point. So 6x minus 4 is greater than 0. 6x is greater than 4. X is greater than 4 over 6 is 2/3. And 6x minus 4 is less than 0. 6x is less than 4. X is less than, again, 2/3. So it's to the right of 2/3, it's positive, so it's opening up. So to the right of 2/3 is going upward. And to the left of 2/3 is negative, is opening downward. Perfect. So a beautiful graph. So notice there's only one x-intercept at 2, and it got 2 imaginaries, and the imaginary ones we couldn't find before until now, doing the calculus, doing the derivative. We see the other curve is occurring here with the inflection point. But they're imaginary roots, and imaginary roots, this cubic only cuts the x-axis at one place. So the other bend is somewhere else in the graph, so the calculus helps us find that. So this ends off on a beautiful question. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that I have on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.